Doing row operations on matrices where there are some unknowns or some letters representing numbers within the matrix is no different from working with matrices which are all numbers. You just have to do your bookkeeping in the normal fashion. Let's run through a quick example to illustrate that. Here's a 2 by 2 matrix in which one of the entries is an unknown number A, and we're asked to find the inverse of the matrix. Well, obviously you can't do this with the row operation tool because the row operation tool only works on numbers, and here we have the symbol A representing a number. So let's just run through it manually and see how it goes. We start out by writing the matrix down on the left and the 2 by 2 identity matrix on the right. And since we want the 2 to become a 1, our first row operation is to multiply row 1 times a half. And when we do that, of course, this is what we get. First column is now finished. We move over to the second column. Where the A is, we would like to have a 1. Well, if that A was a 5, you'd multiply by 1/5. We don't know what the A is, so we just multiply times 1 over A. The row operation 1 over A times row 2 produces a new row 2. 1 over A times 0 is 0. 1 over A times A is 1. Times 0 is 0. And 1 times 1 over A is 1 over A. So we're now done, except we need this 1/2 to be a 0. And the row operation that will do that for us is to do, as usual, row 1 minus a half row 2. Let's just go ahead and do it. Row 1 minus a half row 2 gives us what? 1 minus a half times 0 is 1. 1/2 minus a half times 1 is 0. 1/2 minus a half times 0 is a half. 0 minus a half times 1 over A is minus 1 over 2A. So this should do it. This should be our inverse matrix, and you can check that that's the case. We have our original matrix here on the left, the supposed inverse matrix, which we just calculated on the right, and I ask you to check. Do the matrix multiplication to verify that their product is indeed the identity matrix, therefore verifying that they are in fact inverses of each other.